Now we're going to look at a Venn diagram with three sets. So we have set A, set B, and set C. And they're all overlapping, and so we have 7 different regions here. 8 really if you count the universal set. So we're going to look at each of the 8 regions, starting with the innermost, the darkest shaded region. We're looking at region 5 right here. Okay. If we're looking at region 5, that is going to be in set notation A intersect B intersect C, which means we need the elements in set A and B and C. So all of the elements that are common in all three would be located in region 5. The next we have the next shaded regions 2, 4, and 6. So when I'm looking at this region 2, we have all of the elements that are in A and B, but not in C. So the way we write that is A intersect B. I'm going to do that first, so all of the elements in A and B, and also that are not in C. So the way we put not C is intersect C prime. So this means A and B and not C. So that's very similar for region 4 and region 6. So let's do region 4 next right here. Okay, so in region 4 we're talking about set A and set C, but not B. So the way we write that is A intersect C intersect complement of B, which means A and C and not B. And then our last region in the shaded area is region 6, which means elements that belong in the set B and C, but not in A. So the way we write that is B intersect C intersect not A, which is complement A. In words, this means B and C and not A. And in the next regions, we have our unshaded regions. So for region 1, we have the elements of A, but they can't share any elements in B or C. So the way we write that is A intersect with not B and not C. So this is A and not B and not C. Okay? Okay, so for the next one we have region 3. So region 3 is all of the elements in B, but that are not shared in set A or set C. The way we write that is B intersect the complement of A intersect with the complement of C. In words, this is B and not A and not C. And then our next one is going to be region 7. Those are all of the elements in C, but are not shared in set A and B. So that was going to be C intersect with the complement of A intersect with the complement of B. So this in words is going to be C and not A and not B. And then our last region is all of the elements in the universal set that are not in A, B, or C. So that's in region 8. So that region 8, that basically covers all the way around the outside, but not including anything on the inside of the circles. This is going to be not A intersect with not B intersect with not C, the complements. So not A and not C, not B and not C. So that's how you're going to find out which region you're going to be talking about in set notation. Next we're going to talk about cardinality. The cardinal number of a set A is the number of distinct elements in that set. And that's written as N of A and pronounced N of A. So what is the cardinal number for the following sets? So we have P is the set of all x such that x is a natural number and is less than 10. So if I'm going to be thinking about that, all of the natural numbers, those are the counting numbers, 1, 2, 3, 4, 5, 6, 7, 8, and I have to stop at 9 because 10, you have to be less than it. So n of p, how many elements are there? There are 9 elements. So the cardinal number of p would be 9. Next, we have Q is the set of all x such that x is a day of the week. So how many days of the week do we have? Well, 7. So there are 7 elements in Q. And then on set R, clearly we just have 1, 2, 3, 4 elements listed here. So n of R is 4. Let's do this again with the Venn diagram. N of A. N of A is all of the elements that belong inside the circle set A. So in this red circle set A, I have elements 2, 3, and 5. So that's a total of 3 elements. How many elements are not in A? So n of A prime. Well, that would be 1, 2, 3, 4, 5 elements. 7, 11, 13, 17, and 19 all are elements that are not in A. So that would be 5 total elements. How about part C? What's n of B? So if I'm looking at B, that's everything inside the blue circle here. The values inside the blue circle, the elements are 5, 7, 11, and 13. Again, there are 4 elements here. Next, we were looking for n of the universal set. So everything inside the box. Note those Roman numerals aren't really elements, they're just regions. Those are just ways that we could talk about the regions. So n of universal set is all of the elements inside any of regions 1, 2, 3, or 4. So that's 2, 3, 5, 7, 11, 13, 17, and 19. So the number of the elements of the universal set is 8. Now we're looking at the cardinal number for A union B. So A union B is anything that is in A or anything that is in B. So I'm now looking at this yellow highlighted area. Regions 1, 2, and 3. How many elements are in regions 1, 2, and 3? Well, it looks like there's 1, 2, 3, 4, 5, 6. 6 of those. And then the last one we're looking at is the number of elements in A intersect B. Intersect B is the middle part. So we're talking about region 2 only. So for region 2 only, there's only one element inside region 2, and that's the element 5. So n of A intersect B is 1.